All right, statisticians, today we're going to look at what we do when we have quantitative data. So remember, there are two different types of data. There is quantitative and there is categorical. And categorical, if you'll remember, that is done when there's categories, when it does not make sense to take an average of your data. Where you're looking at quantitative data here, quantitative data is typically numbers. Quantitative data, there is continuous quantitative data and there is discrete. Continuous, there are no gaps. That would be something that you could measure. Where discrete would be there are gaps in between the data. So number of AP classes that you're taking would be a great example of that one. Quantitative data, it would make sense to take the average. So speaking of average, that's the first thing that we're going to look at today. One of our measures of center. So I'm going to go back to our SOCS acronym, SOCS. S stands for your spread. That's one of the S's. I'm sorry, the first S typically is your shape. It can be spread. Both of those S's are in the SOCS acronym. Your O is your outlier and your C is your measures of center. Mean is one of your measures of center. So to find the mean, and another way, something that we have called the mean, is your average values of a set of observations. You're going to add up all your numbers and divide by the number of observations that you have. So just so you can see a little bit, this symbol right here, we call that your X bar. X bar represents the mean. N is the number of observations that you have in your data set. So again, just kind of looking through some of the symbols that you're going to be seeing. X bar refers to the mean of your sample, where later on in some of the chapters that we look at, you're going to see this goofy looking M. This is the Greek letter mu, M-U, and that refers to the mean of a population. We will talk about that a little bit later. Now, means, they are sensitive to what we would consider outliers or extreme values. Two words that I want to make sure that you understand off to the side. One of these words is called resistant versus non-resistant. Resistant data, or a resistant data point, is one that is not affected by extreme values. It is not changed. You are resisting something. You don't want to change. So resistant typically would be your medians. Those are not necessarily affected or affected very much by extreme values, whether they're high outliers or low outliers. So they don't change with outliers. And then there's this other word, non-resistant. Non-resistant, these go with the flow. This would be your mean. Okay, your mean is absolutely affected by outliers. And an example that we have is Jeff Bezos. He is a billionaire. If he moved into the town of Schaumburg, we definitely know that the average income would drastically increase. But the median income would not change very much, whether Jeff lived here or not. So non-resistant, they are definitely sensitive to those extreme values. They are pulled in the direction of those extreme values. They change with outliers. So we're going to see these words resistant and non-resistant. So your mean would be considered non-resistant. So how we interpret it. When it comes to stats, we usually use full sentences when we describe something. We don't just say mean equals. So you would say the average value of calories in a cheeseburger, we'll see that here in a minute, is, and insert the value of the mean. Okay, you're going to use that word average in there. So then we have the measures of centers, the median. Okay, we've got mean and we've got median. Your median is the midpoint of a distribution. The number such that 50% of the observations are smaller and 50% of your data or your observations are larger. To find the median of a distribution, 1, arrange all observations in increasing order. If you have an odd number, the median is the center. But if you have an even, then you're going to average the two center points together, just like you would have done in past math classes. Medians are resistant. So they are a resistant measure of center, meaning they don't change with extreme values. They are not greatly affected by extreme values. So again, median, half is above, half is below. When you start talking about the median in your conclusions, you would say the typical value. Okay, that would be another word that you say. So again, take a look up. Mean, we say the average value, where median, you would say the typical value. So here we have some data for the amount of fat grams for McDonald's chicken sandwiches. We can see all of those data points in there. So if we are trying to calculate the mean, what we would do is we would take each of those fat grams and we would add them together. I'm going to put these ... meaning we're going to do all of that, and you usually end it with that last data point. That would be an acceptable way on the AP exam to show what you're doing. Part of the AP is you need to show them you know what you're calculating, and there are 8 data points in there. In total, all of the data adds up to 139. We divide that by 8 to find our average. And we see that the actual mean comes out to be 17.375. With this, what we would say is we wouldn't just leave that number in there. We would have that sentence that we kind of talked about up at the top. So that sentence would say the average value of And what are we talking about? What is this context? Well, we're talking about fat, the amount of fat for McDonald's chicken sandwiches. So we got to put that in there. So the average value of fat in McDonald's chicken sandwiches is 17.375 grams. So put it in context. That's super important in this class, answering your questions in context. So then it says calculate and interpret the median. Well, the median, we top, bottom, keep going up. And what we're going to find is we have 2 middle data points. So in order for us to find the median when we have 2 in the middle, we would add those 2 together and divide by 2. So this would come out at 16.5. Again, in context of us answering this question, we would use that sentence above, the typical value of fat in McDonald's chicken sandwiches is 16.5 grams. Make sure you answer in context. So the third measure of center is mode. We don't usually ever talk about the mode as a true measure of center because it's not a great indicator of a measure of center. We definitely know that mode is the most common value or peak, but this does not tell us what the center of our data is. We typically describe the center, whether being your mean or your median. So then we have something else called your spread. So again, with SACS, we have shape. That is your symmetrical, your right skew, your left skew, or even uniform. We have O for outliers. We'll talk about outliers here in a minute, how we calculate those. We have our C, our measures of center. This is typically mean or median. And we have our last S for spread. Spread can be talked about with variance. I will definitely say to you guys right now, we're not really going to use variance very much. Right now, we're only going to use variance in order to calculate standard deviation. This is a important data point or important concept, however, not very important to us right now. So right now, all you are going to see is the fact that variance is equal to your standard deviation squared. The standard deviation we are going to look at is that S sub x, because we have a sample. Again, later on, we're going to look at population standard deviations, and that's a different symbol. So when you are using the mean, so this is important that you are only using variance or standard deviation when you use the mean. So when you're using the mean as a measure of center, it is appropriate to use variance and standard deviation as a measure of spread. Usually we only address standard deviation. However, variance is used to calculate standard deviation and has some important properties later. The standard deviation measures the, I'm going to say this word, it's not really mathy, but it's the average-ish. And I say this word ish because if we look down at the formulas for it, you're going to see that we don't divide by n, we divide by n minus 1, which is why I don't want to say the word average. When we found the average on the page before, for the mean, we divided by n. This time we divide by n minus 1, so that's why I'm going to use this word average-ish. So what standard deviation is it measures the average-ish distance each data point is from the mean. We find that standard deviation by taking the square root of the variance. So variance is standard deviation squared. Okay, so what we can see what's going on mathematically, this is not a formula that you have to memorize. This is on the formula sheet, but what this x sub 1 is, this is your data point, and you're going to subtract the mean. You're going to square that number. The reason why we square it is makes everything positive. The purpose behind squaring it instead of taking the absolute value is actually found in calculus. In calculus, it's easier to integrate or even take the derivatives using squares. It's way easier than working with absolute values. So we square things to make everything positive. Okay, the reason why we divide by that n minus 1 is it actually gives us a closer and more accurate value. And you just got to trust me on that. So how we calculate this by hand is you would take your data point or each data point, subtract the mean, square it. Add it on to the next data point minus the mean, squared, and so on and so forth. Finally, take the square root of all of that, and that would be your standard deviation. A quick, simple example would be if I had these three data points, 10, 12, and 14. I would add them all together, and to find the average, which is our x bar, 10 plus 12 plus 14 is 36 divided by 3. This gets me 12. So what you would see in your work is I would have my data point minus the mean squared plus the next data point minus the mean squared. And finally, my last data point minus my mean squared, all divided by 3 minus 1. What this would come out as, and I don't have the decimal for it, and you would want the decimal in this case, is this would be the square root of 10 would be your standard deviation. So just so we see it, symbols, SX refers to the standard deviation of a sample. You're going to see that in your calculator. You're also going to see in our calculator, it says OX. This refers to the standard deviation of a population. And standard deviation is always greater than or equal to 0. It's always greater than or equal to 0. And it is only 0 when all of the values are exactly the same number. It's because, again, standard deviation talks about the average-ish distance each data point is from the mean. So if your standard deviation is 0, that means they aren't away from the mean. The bigger the standard deviation, the more spread apart your data. That means they are further from the mean. The standard deviation, like mean, is sensitive to extreme values. We would call this, again, when it is sensitive, when it does change, when there are outliers thrown in there, we would call that non-resistant. And in context of the question, how you would say it is, we would say the average distance. When you're answering, you have the standard deviation, you're coming up with that sentence, you would say the average distance of the data values from the mean of the distribution is. So another thing that we can use to talk about the measure of spread is your IQR. This is called your interquartile range. And range in general only looks at the highest and lowest values, which could be outliers. So when we look at the IQR, it can improve our description of the spread. So what this things that we do or how we calculate it is your median divides your data into the first half and the second half. And then what we're going to do is we're going to find the median of the first half. And that will divide the data into the first and second quarters of the data. This value is called your first quartile, or we call it Q1. And then if you go to the second half of the data, so we went on the left side of the median, we found Q1. If you go to the right side of the median and find the median of that half, that is the median of the second half. We'll divide that data into third and fourth quarters of the data, and this is called your third quartile, or we call it Q3. And the range between those values, between Q3 minus Q1, that is called your interquartile range. So here's what you're going to see. You're going to see, it's called your 5-number summary. You're going to have your minimum. And then you're going to have your Q1. 25% of your data falls between your minimum and your Q1. Then you're going to have your median. 25% of your data falls between Q1 and your median. You have your Q3. And out to your maximum. Your IQR is this chunk right here, this middle 50% of your data. Now, the interquartile range is resistant, meaning it does not change. It is not affected to outliers since we cut out extreme values on both ends when we find those outliers. The median itself is not included when calculating the quartiles. So the phrase that you could say in your description or your write-up is the middle 50% of the data has a range of, and go ahead and insert your IQR. So here's what we're going to do as far as actually calculating the IQR. So we have the same fat content from McDonald's. So when we go ahead and calculate that IQR, we can see that we have 8 data points. And for us to find that middle is actually in between 16 and 17. We calculated that before. So right here, we calculated our median to be 16.5. So above the median, the top half, what we're going to see is that falls right in here for our Q1. So we're going to take 10 plus 16, divide that by 2. We see that my Q1 would be 13. And I'm going to do the same thing down at the bottom. I'm going to split that bottom half in half, and that's going to give us our Q3. 20 plus 23 divided by 2 is 21.5. So what we would say to find and interpret our IQR, we would take our 21.5, we would subtract our 13. This is our Q3 minus Q1. We would have an interquartile range of 8.5. So what we would say is that 50% of the chicken sandwich fat content has a range of 8.5. So 50% of chicken sandwich fat content has a range of 8.5 grams. So if we're going to go ahead and calculate the standard deviation, we found in the prior problem that our X bar, our mean, was 17.35. So to calculate the standard deviation, it is big square root and we would have 9. So you're going to take each of your data points, 9 minus that mean of 17.35. You're going to square that number. Add it on to the next data point. So 10 minus 17.35, square that. And again, it's okay if you don't show all of it, but you do need to show the first couple and the last. So we would end that with 28 minus that 17.35 squared. And all of that would be divided by, again, this is your n minus 1, which in our case is 8 minus 1. Our standard deviation then gets calculated out, so we would say Sx equals 6.323. The phrasing for us to finish this up, because remember it's always done in context, we would say that the average distance from the mean is 6.323. So we call our 5-number summary. This will be important for us when we start to do box plots. This 5-number summary is a way to summarize a distribution numerically. It consists of the minimum, the Q1, the median, the Q3, and the max. So our 5-number summary for our McDonald's sandwiches is our minimum was 9. Our Q1 was 13. Our median was 16.5. Our Q3 was 21.5. And our max was 28. That is our 5-number summary. Now, the final question is, how do we know if a value is an outlier? So here's what we do. You're going to go ahead and you're going to calculate the IQR. Next, you're going to take your IQR and you are going to multiply that value by 1.5. From there, to find your lower bound, you're going to take your Q1 and you are going to subtract your 1.5 times the IQR. And anything lower than that lower boundary is considered to be an outlier. To find your upper bound, you're going to take Q3 and you're going to add 1.5 times the IQR. And anything bigger than that value is considered to be an outlier. So let's look to see if we have any outliers for our chicken sandwiches. We found our IQR was 8.5. So if I take 1.5 times 8.5, this gets us 12.75. So for me to do the lower boundary, what I am doing is I'm taking my Q1 and I'm going to subtract 12.75. Well, if you look at your 5-number summary, our Q1 was 13. And when I subtract 12.75, that leaves me with a lower boundary of 0.25. None of my data points are lower than 0.25, so there are no outliers on the low side. Now let's check with our upper. For our upper boundary, what we're going to do is we're going to take Q3 and we're going to add that 12.75. Well, my Q3 was 21.5. I'm going to add 12.75. This would give me the value of 34.25. And none of my chicken sandwiches had fat content that high. So I would also say that there are no outliers on the high end. So because there are none on the low and none on the high, all of our data would be considered all good.